Hello everyone, good evening. Good evening. How are we all doing today? How was our day? I hope it went well. Welcome to another class. This is Introduction to Firewalls. So let's look at our objective. So first objective is to understand the basic concept of firewall and its importance, identify the different types and key components of firewall, and explore how firewall filters network traffic, explore the different types of firewall rules, and discuss the challenges of implementing and managing firewalls. Alright, so let's get to it. So number one, firewalls. What exactly is a firewall? If you say, oh, firewall, what does it mean? You understand? So a firewall is a network security device or software that acts as a barrier between a trusted internal network, such as a corporate network or home network, and an untrusted external network, typically the internet. So basically, what is a firewall? A firewall is basically what sits between your company's network and the actual internet. So as an organization, right, your company is not an island, right? You want your staff members to be able to connect to the internet, you want them to be able to browse and stuff like that. You also want, if you are a company that have a website, you host like a web server, you want those people to be able to access your web server that's in your organizational network. So a firewall is that device or that software that sits between the organization network and the internet. You get, so the trusted network in this case is the organization network, while the untrusted network is actually the internet. So the primary purpose of a firewall is to monitor, filter, and control incoming and outgoing network traffic, and allowing or blocking data packets based on set of predefined security rules and policies. So the main goal or the main reason why you have a firewall is for you to be able to monitor, number one, filter and control incoming and outgoing traffic. So when they say something is incoming, it means that from the internet it is coming into your network as an organization, and when something is outgoing, it means that from your organization it is going out. So let's do an example. So if you have an employee named Ade, and employee wants to browse Google now. So what the employee is sending a and say, oh, what is the name or what is the meaning of firewall? When that traffic goes out of the network, that is called outgoing traffic. Then when Google is responding to that person, that is called incoming network. Or another example is when a particular user, maybe a customer, wants to access the website of that company or of that organization, that is when it's inbound traffic or incoming traffic. So why is firewall important? Why are we talking about firewall today? What do you think is the reason why, okay, why should we discuss firewall? Why should we have firewall in our organizational security structure? Number one is security, network security. So firewalls are a fundamental component of network security. They provide a layer of defense that helps protect the network from unauthorized access, cyber attacks, and malware. So basically, one of the importance of firewall is for network security. So in order to secure the network of our organization, to ensure that no attacker or no attacker, no malware person, no malware is coming into your network, you understand? That is the reason why you are using firewall. So it protects, since it serves as the middle guy between your network and the internet. So it will prevent malicious attacks from the internet to affect your network. And the next point is access control. Firewall enforce access control policies, allowing organizations to define who can access the network and what resources they can access. So access control is another importance of firewall. So for firewall, you can set up rules and set up policies, you understand? And these rules and policies is what guides the firewall to decide, okay, I would allow this person in, I will allow this particular traffic, and I won't allow this particular traffic, and which indirectly helps to do access control. Then the next point is threat prevention. Firewall can detect and block known threats such as viruses, malware and intrusion attempts. So threat prevention in the sense that if let's say there's a file, maybe one of your users wants to download a file or download something from a malicious website. First of all, if you arrange your firewall very well, if you configure your firewall very well, your firewall can be able to detect that okay, this particular this particular IP address is known as a malicious IP address. So it's going to block the user from even having access to that user address. Then the next point is that to not allow the user to be able to download that particular device. Because that's the goal of firewall. That's one of the importance of firewall is for threat prevention. And the next one is traffic filtering. So firewall inspect network traffic and filter out unwanted or potentially harmful data packets. So it does that traffic filtering. So what does it do is that for each packet that is coming in and going out, it checks okay these packets are they harmful packets or they are useful packets, and then it can block specific ports. So let's say a particular port is known for a particular kind of bridge. You understand? You can block anybody from having access to that port, can block specific protocols, it can block IP addresses. I talked about the fact that maybe you because there is a list of malicious IP addresses and that information keeps updating every day. That information keeps updating every day. You understand? So um you can create your you can configure your firewall in such a way that you can your firewall can be able to detect anytime anybody is trying to communicate with that malicious IP address. Then the next one is application layer security. So next generation firewall provide application layer filtering, which allows them to identify and block specific applications or services that might pose security risks. So another thing is this application layer security. So apart from just looking at the network, apart from just looking at the network and everything, it can also look at the applications on a particular host or a particular device or in the network. Let's say there is a shared resource or a shared application that everybody is using across the network. I can also look at those things and prevent threats from happening on those applications. And the next one is data loss prevention. Firewall can be configured to prevent the unauthorized transfer of sensitive or confidential data outside the network, helping organizations maintain data security and compliance. So the way it is that you can be able to configure your firewall in such a way that if you are transferring sensitive company information or confidential information, it will prevent you from actually doing making such transfer over the network. Then the next thing is privacy and confidentiality. Firewalls safeguard the privacy and confidentiality of network communication by controlling who can access, view or modify data transmitted over the network. So yes, there's privacy when it comes to the firewall. So the way it is that with your firewall, you can be able to configure who has access to view a particular information over the internet, who can modify a particular information over the internet. You get. Another reason why firewalls are important is monitoring and reporting. So oftentimes firewall provides login and reporting capacities, allowing the network administrator to monitor network activities, analyze security incidents and make informed decisions to improve security. So one good feature about a firewall is that it always logs events that happen on the network. When maybe somebody is communicating with the when maybe when an employee is communicating with another device outside of the network, that information is logged. You get. So this can help with troubleshooting. Let's say for example, let's say two servers usually talk to each other every time. All of a sudden they can't talk to each other. With monitoring and reporting, you can be able to check and be able to look at the logs, and then you can now troubleshoot and figure out what exactly is wrong, you get. Then also it can be used for network security. So you can use it to monitor, analyze security incidents. Maybe there's a security incident that occurred. You can use the logs that you get from the firewall to be able to investigate and find out, okay, where did this thing start from? You understand? So these are the reason why firewall is actually really important. So what are the different types of firewalls? So number one, we have packet filtering. Packet filtering firewall. Packet filtering firewall operates at the layer 3, that is the OSI model, that's the network layer. So they examine packets of data and filter them based on predefined rule, such as source address, destination address, um port number, protocol, you understand. So packet filtering simply means that this firewall will check the individual packets, you get, and the packets usually happens in the network layer, you get. The packet which usually happen in the network layer. So it examines and filter them out based on destination address, source address, port number, protocol. So let's say for example now we want to prevent everybody communicating from a particular IP, you understand, a particular destination IP. So when any packet is passing through, whenever packet filtering happens, right, it checks for each packet and say, okay, that this particular IP address, is it here? If it is here now, it will quickly drop it, because you've already given the rule, the predefined rule, that okay, if there's any traffic from this particular address, we are going to remove that communication, or we are going to remove that packet, we get. So the next one is stateful inspection firewall. So stateful inspection firewall is also known as dynamic packet filtering firewall and operates at the network and transport layer, that is layer 3 and layer 4. They maintain state information about active connection, allowing them to make decisions based on the state of the connection. These firewalls are more secure than the simple packet filter and provide better protection against certain attacks. Alright, so let me explain this one now. So when it says stateful inspection firewall, it means that it wants you to remember the state, the last state that this firewall is. You understand? And this thing happen in your transport and your network layer. So basically what it does is that it maintains an active connection. Usually for the packet filtering, once one packet comes, it just filter, and if it's allowed, it's allowed. If it is denied, it's denied. But then for stateful inspection firewall, you have to remember the state of the previous information that had passed. You understand? That way it can help you track over a long period of time. It can be able to help you track or user behavior, you get, because it's stateful, right? It can be able to understand, or like it remembers or keep track of the active connections, you get, in the firewall. Then the next one is proxy firewall. So proxy firewall works as the what acts the application layer. It acts as an intermediary between the internal and the external system. They intercept and inspect traffic of the application layer, making access decision based on the content of the traffic. Proxy firewall provides deep packet inspection and enhances security and control over applications and services. So for proxy firewall is basically at the layer 7. So this basically means that it's doing a more in-depth checks, or a more in-depth inspection on this particular, on the packets you get. So it will inspect, um giving doing like a deep packet inspection, so that it can be able to enhance the security. So it's more of like while the other was stateful and packet filtering, right, are happening in layer 3 and layer 4. This proxy is happening in layer 7, you get. The next point is next generation firewall. So next generation firewall combines the features of traditional firewall with advanced capacity, including intrusion detection, application level filtering, malware inspection. So for next, that's for next generation firewall. It's a firewall but it has additional filters, things like advanced capacity, intrusion detection and the rest, you get. So they can identify and control specific applications and server, making them more volatile in dealing with common threats, you get. So this is a new generation firewall, right? These are the features. Then another type of firewall is circuit level gateway. This one works at the session layer, that's layer 5, and creates a circuit which is a we can call a proxy for each connection. They don't inspect packet con ten t but verify the authenticity of the connection, making them suitable for carrying specific type of traffic. So basically this circuit layer gateway is not examining the con ten t of the packet but rather is examining the how like authentic the person that made this connection is, you understand. So what is mainly looking at is not, oh, what is the content of information that is being passed. No, what is mainly looking at is that, okay, this person that is generating this information, is this person correct, like is this person a valid user, right? It's not we hope it's not an impersonation attack and stuff like that, you get. So the next one is application layer gateway. Application layer gateway operates at the application layer and are specialized proxies for specific application or services such as FTP or HTTP. They provide deep inspection and control over application specific protocols. So let's say on a particular system or in a particular server, there's a particular firewall, or rather there's a particular application in your organization that you need file transfer protocol for, you understand, or HTTP protocol for, right? First of all, like this application firewall will check that, okay, this particular protocol is allowed on this application, you get. So the application firewall will check, let's say the application is let's use Microsoft Teams now, right? So let me use so that I can use something that is relatable. So let's say it's Microsoft Teams that is the application. So the application firewall will not check that, okay, Microsoft Teams has the ability or has the right to be able to access protocols like FTP or HTTP, you get. So they provide more in-depth inspection. So they are more on the application layers, on the application layer rather. The next point is host-based firewall. Host-based firewall are installed on individual basis such as computer or servers. They protect and specify device they protect the specific device on which they are installed by controlling incoming and outgoing traffic based on local rules. So host-based firewalls are basically firewalls. Now we are talking about how firewalls sit between the organization network and the internet. But host-based firewalls mean that, okay, this firewall sits on the particular device, sits on a computer, sits on a laptop. You understand? That is host-based firewall, sits on a desktop. Okay, so you are saying that this, apart from the firewall that covers the network, the on this particular host, on this particular laptop, there is a firewall for it. You understand? Most Windows devices make use of Windows firewall, you get. So we are moving on to the key components of a firewall. So um one of the key components of the firewall is the packet filtering engine. So this is the core of the firewall and handles the inspection and filtering of network packets. So it is one of the core functionalities or one of the core of firewall. What does it do? It handles inspection, right? So it will examine, okay, what are the attributes of this packet now? Okay, what is the source address? What is the destination address? What is the port number? what is the protocol. And then with all this valuable information and more, of course, with all this valuable information, to now check, right, that okay, from my predefined rules, you understand, from the rules that have been set, you understand, are these particular things allowed in this environment, or are they denied, are they blocked in this environment. So when it checks that, it's now okay, this one is allowed, oh yeah, go, this one is not allowed, oh yeah, be blocked, you understand, or be dropped, you get. So the next point is rule based. So the rule based is a set of predefined rules that specify how the firewall should treat incoming and outgoing traffic. So basically, rule based is like it's more of like a set of rules, right? Predefined rules. So these are rules that indicate or let the firewall know how they should treat incoming and outgoing traffic, because each what do you call it? Each kind of traffic has its own way, or each kind of packet has its own way that it should be handled. So it will check or determine whether a particular traffic should be permitted, a particular traffic should be denied, or a particular traffic should be set for scrutiny, maybe set to their need that okay, I don't know, come and see, oh, does this make sense or this not make sense? You get. So the next point is stateful inspection module. So stateful inspection is a key component in the modern firewall. It tracks the state of active connection and help firewall make intelligent decisions about allowing or denying traffic. You get. So stateful simply means that it keeps track of active connection. So it ensures that okay, if I'm communicating with this person, I keep track of all my communication with this particular IP address. You understand? This module is responsible for maintaining the state table, which records the current state of each connection. So it records the current state of each connection. So okay, as a particular communication is going on, you get, it records that state. So how do firewalls filter network packets? Number one is the first step is packet inspection. When a network packet arrives at the firewall filtering process begins. The firewall inspect the packets to gather information such as source and destination IP address, source destination port number and protocol. So packet instruction does mean that okay, you want to gather information about a particular packet. Let's say communication has started, right? And you want to inspect that okay, this information that is coming today, this information that is coming in is actually supposed to work. So what are you supposed to do? You're supposed to get valuable information that you can use to test against the rules in the rule base. So first of all, you need your source IP address, destination IP address, port source port, destination port, protocol. So those are the key things that you need, you understand. And then you can now um check. So what is going on is that the firewall would check, okay, this packet is coming in, right? Let me check that all these details are there. Once the details are gotten, right, it's now go to the next step called the rule evaluation. So with this next step now, the firewall will now compare the attributes of the packet to the rules defined in the rule base. So what happens is that okay, the first step is that the firewall will collect the packet informations. After collecting the packet information, it will now go and compare with the rules in the rule base that okay, with this particular information, can this particular packet pass through? You understand? So the next thing is sequence rule evaluation. The firewall evaluates rules sequentially, starting with the first rule in the rule base and proceeding in that order. So the firewall evaluates sequentially. So the first rule that is in that rule base is the first rule that it will check the packet information against, and then it will keep on evaluating it. Then the next point is rule order. Rule order is important because in most cases the first rule that matches the packet attribute is applied and subsequent rules are not evaluated. This means that rule order can have a significant impact on the firewall behavior. So very important to notice that the first rule that matches a particular firewall event you get will be applied, and in most cases, right, not in all cases, so in most cases the subsequent rule might not be applied, you get. So rule order is very important. So if you want a particular rule to respond, or you want a particular rule to apply to this event, you need to ensure that it is stated first, you get. So the next point is allow or deny decision. It is a rule, if a rule matches the packet attribute, the firewall can make an allowed or denied decision based on the action specified in the matching rule. If the rule action is allowed, the packet is permitted to pass through the firewall, and the firewall may log the event for auditing and report purposes. Alright, so let me just explain. So the next one is allowed and denied decision. So now the first step was to gather the packet information, then the next step was to pass that information across the rule in the rule base, and then we talked about how the rule follow a sequential form. So if you need that particular rule to implement first, you need to ensure that you bring it up first. Then the next point is the allow or deny decision. So allow or deny decision simply means that, okay, now that we have checked that matching rule now, what does it say? Is it saying that this traffic should be allowed? Is it saying that this traffic should be denied? So whatever the response is, that's what the firewall will perform. You get. Then the next point is logging and reporting. Firewall often maintain logs of network activities, including allow and deny traffic. This can be useful for monitoring and troubleshooting. So basically, after it has said, okay, this traffic is allowed now, this traffic is denied now, it will log it, you understand, so that when there's a need for auditing, if they say, oh, um, how come all the traffic in this place are being denied, you show them, okay, this particular what do you call it, this particular traffic, right, when the firewall engine checked, you understand, it said that it's going to be dropping all this particular traffic, you get. So the next thing is stateful inspection. Stateful inspection, this one is for firewall, for stateful firewall. So stateful inspection maintains a state table that keeps track of the state of active connection. When packets are part of an established connection, the stateful allows them by default, even if they don't match a specific role. So basically, like, let's say first of all, um you are trying to transfer something, let's say from inside the organization to a particular website, right? And we're using a stateful firewall. So it will either establish a connection, it will do the whole packet tracing, sorry, it do the whole packet filtering, the rule base, everything, allow denied. So if particularly that particular event has been allowed, right, and by using stateful, it means that it's going to allow the remaining packets, you understand, without having to go back and do the whole test from the beginning again too now. Then the application layer inspection. So for some firewall, particularly the next generation firewall, are capable of deep packet inspection as the application layer. This firewall can identify and control specific applications and services, enabling more granular control and security. So with application layer inspection, right, it has the capacity to do deep packet inspection. Then the next one is alert and notifications. So firewall will generate alert and notification when they detect suspicious or harmful traffic that doesn't match any rule. Yes. So if at the end of the day this particular event, right, does not match any rule, you get any rule in the organization, then a call needs to be made to, or more of like an alert needs to be made to the administrator. You understand? So the firewall will send an alert to the administrator. They can configure it in such a way that the alert can be sent through mail, or the alert can be sent through a ticketing system. You get. So now there are actually like different types of firewall rules you get. So we have been talking about firewall rules, going to check the firewall rules. Yeah, but there are different kinds of firewall rules, different types of firewall rule. Number one rule is the allowed rule. So allowed rule is also sometimes known as the permit rule. So permit network traffic that matches a specific criteria. If a packet satisfies the condition outlined in an allowed rule, it is allowed to pass through the network. So allowed will simply means that okay, somebody wants to pass through the network, there are certain criteria they must meet. So if they can fulfill that criteria, right, they are allowed through the network. And the same thing goes for denied rule. There are certain criteria that needs to be met for that particular traffic or that particular packet to go into the network. You get, so if that particular conditions are not met, then the um the firewall rule will now be denied, or that is what leads to it being a denied rule. You get, because denied rules are simply meaning that okay, this particular condition was not met, that is why this is denied. You get, or this is denied rather. So the next one is stateful rule. So these are based on the state of the connection. These rules allow traffic that is part of an establishing connection or session, while denying traffic that don't have a corresponding state. So basically, the stateful rule simply keep is a type of firewall rule that keeps track of the state. You understand? It keeps track of the connection that is currently ongoing, and then it allows gives permission, right, to a particular to some particular traffic or some particular packet that is still part of that connection. You get, so let's say for example two devices open a connection. You get, so a firewall, let me use this now. Somebody from the organization, let's call him Peter, is communicating with another person from outside the organization. You get, they're sending text messages. You get, so while the information, like let's say you send one text message now, while every of that text message is transferring to that person, or let's say you are sending a file, good, let's use a file. While that whole file is transferring to that person, you get, at the beginning, the first packet, you know how you do transfer, when you want to transfer a file over the internet, it transfer as packets. So they'll break them down into packets. We've done the OSI layer before. So when it breaks it down into packets, right, and you now want to transfer it one by one. So the first packet will first of all make the communication through the firewall, and then to establish a communication or establish a connection between the internal person, which is Peter, and the firewall, the internal person's device, which is Peter's device, and that firewall. You get, so while the file is still sending over the internet, that connection will not break. Everything will send at once. You understand? So the next point is stateless rule. So in contrast to stateful rule, it does not consider the state of the connection. They make decisions solely based on the attributes of the individual packets. You get, so for stateless rule, you will have to every time. So let's say for example, we're sending a file of 5 MB now, or a file of let's say 100 MB now, and each of the packets is going in one MB at a time. You understand? Um, for the first MB that is going for stateless, it will pass through the process of okay, get the information, filter, and then decide whether it's allow or deny. And when you are going to the next MB to still do the same thing. But if it's stateful now, once that first one has passed and that first one is allowed, every other one, as long as it's part of the file that you are sending, you understand, every other packet that is coming in will actually be allowed. You get, so that is the difference between stateful and stateless. So the next thing is inbound rule. So inbound rules or incoming rules are applied to what they call it, to traffic entering a network or device. Now I explain what inbound is. So inbound means that okay, something is coming into your organization. So just imagine that this is your organization. Any information or any traffic that is coming into your organization is inbound, while any traffic that is leaving your organization is outbound. So basically, inbound just simply means that okay, these are rules concerning traffic that are coming into the organization. Okay, so okay, if this particular kind of traffic is coming in, deny it. This particular kind of traffic that is coming in, accept it. It all depends. You get, but inbound rules is basically talking about direction. So if the information or if the packets are coming from outside into the network, is inbound rule, right? While in the information is coming from within and going out of the network is outbound rule, you get. So it basically specifies that okay, for information or for traffic that are going inbound or outbound, what are the permissions, or what should we do? Should we accept? Should we deny? Should we approve? All the stuff. It's just based case by case basis. You understand? So the next point is default rules. These are rules that are applied when no other rule matches incoming or outgoing traffic. So if no other rule matches incoming or outgoing traffic, an automatic default action is taken, like you get. So at the end of the day, so it might be deny all. So the default action might be deny all. If nothing meets the criteria, just deny everything. You get, or it can be just accept it. If it doesn't meet the criteria, just accept it whenever, like just that's the default, you understand? So usually it is very advised to use deny as default. So in case something doesn't work out, or it doesn't no rule can match this particular bracket, or can match particular traffic that we are seeing, we get just move everything to denied. Then the next one is implicit rule. So these are predefined rules that are automatically applied by firewall. They're often used for basic firewall operations to ensure that firewall does not operate in a completely open or closed state. So implicit rules are like predefined rules. So they are rules that are applied automatically to the firewall. The next one is explicit rules. These are user defined rules that are created and configured by the administrator to specify how firewall should handle specific types of rules. So these are usually rules that have like special cases we get, or you want to do custom rules. So basically, explicit rules are rules that are created and configured by the administrator, and it specified or how the firewall should handle some specific kind of traffic we get. And this explicit rule takes, like, it happens over an implicit rule. Let's say for example a particular packet comes in, right? And then just check that okay, just check that okay, I can use the implicit rule for this, or we can use explicit rule for this. We'll go ahead with the explicit rule. Then the last one is access control list. So access control lists are a list of permissions attached to specific network devices, such as interfaces or router. So a list of basically access control list is a list of permissions attached to specific resource, network resources. So like permissions in the sense that okay, who can edit this particular network device, who can edit particular network resources, you understand? So that is basically access control list for you. It's basically just a list of people that have the right, or people that have the privilege, right, to access particular information. So the next thing is the challenges of implementing and managing firewall. So what are the challenges of implementing and managing firewall? Number one, we have the complex rule management. So complex rule management in the sense that even as the organization keeps growing, even as the organization keeps growing, right? It might be difficult to manage a large rule base. You understand? Rules can become complicated, especially if they are like custom rules. You understand? They can become too complicated and difficult to manage. You get. The next one is rule conflict and misconfiguration. So misconfiguration and rules conflicts can in internetly open security holes or block legitimate traffic. So basically this just means that misconfiguration can happen in the sense that when you're trying to configure a particular firewall rule, you might end up mistakenly doing something else than your intention. Let's say you wanted to deny the rule, but you now ended up making it an accept true. You get, so that way you would end up opening the doors for attackers or for illegitimate traffic to happen. You understand? Or sometimes you can end up even blocking the right traffic to happen. You get? So sometimes there might be road traffic in the sense that two or three different roads are speaking towards the same situation and are giving contradictory verdicts. Maybe two of these roads, let's say there's one that is accept, there's one that is deny, and they're talking about the same thing. So this is what is root conflict, because two or more rules are speaking about one topic in a contradictory light. Then the next one is policy consistency. Maintaining consistent security policies across multiple firewall instances can be challenging. Inconsistent policy can lead to security gaps and vulnerability. So we have policy consistency. So the thing is that we have to maintain some certain level of policy consistency. You understand? So that's just to ensure that there is no gap when it comes to security and there's no vulnerability. We get? So if there's a policy, let's say there's a new policy that okay, we need to do this and this, we need to implement this on the firewall. We get? Let's say recently maybe they find out that oh, a particular port has improved to be malicious. Right now, let us block the port. You need to be up and doing your game to ensure that okay, your network firewall has been able to block the I'll be able to block events, or I'll be able to block packets coming from this particular port. You get? So that is policy consistency, making sure that you are keeping track of the new policies that are going on and the new ones that need to be implemented on your firewall. You need to make sure that you implement them. Then the last one is rule auditing and documentation. Keeping a comprehensive documentation of firewall rules, changes and justification is essential. Many organizations struggle maintaining accurate and up-to-date documentation. So updating documentation can be a very stressful thing, especially when maybe as the administrator guy, you are not really clear on how things work. You understand? You are still trying to figure things out. You get? So by the time you are suffering yourself to you are done figuring out the configuration, you will not have the energy to go and start writing documentation. Writing documentation is very important. In fact, it's one of the most important things, because after a while, it's either you forget what you did, or you can even forget, oh, why you did not do something like this. You get? You might even forget, but that documentation can be able to remind you. Or in case of company handover, because you won't work with your organization forever, because you're supposed to have proper documentation so that even someone takes over from you, they have proper documentation. You get? And what to know what is wrong. And then also documentation will also help when it comes to troubleshooting. You get? So that's it. Then the next thing is performance, okay, challenges. And that challenge is performance impact. So sometimes firewall can introduce latency, which can affect the network performance. So based on the weight, or like based on the um based on the impact, right, of the firewall on the particular on the network, you get, it can make the network, it can actually affect the network performance, you get, especially when it's doing packet inspection. So just imagine that you're supposed to send, even though it like works in like milliseconds, right, you're supposed to send 100 MB worth of data, right, and the map is going 1 MB packet at a time, and it's now doing deep packet inspection. It should take a longer period of time. We get? So that's why we're talking about performance impact. So sometimes some firewall can end up affecting the performance of the network. The next one is log management. So collecting, analyzing and retaining firewall logs can be source intensive. So sometimes, right, the logs can be a lot because it's firewall and everybody must communicate to your firewall. You get? So the firewall logs might be a lot, you get, which makes it resource intensive. And the next one is rule optimization. So from time to time you have to go through the rules and optimize the rules for efficiency. This can be like kind of cumbersome, you get, especially when it is somebody that hasn't really wasn't there when they were working on any of those rules. You get? But it's important that from time to time we go in and optimize the rules, we get, and prepare it, like just just make so that you can improve efficiency, you understand, and the overall performance. And then the next thing is resource constraint. So for smaller organization, resource can be an issue, right? Um and in terms of not just in terms of finances to invest in firewall, but also in terms of staff. Sometimes you need to get like um an expertise when it comes to managing firewall. Yeah, because some problems might see manage firewall can be looking easy at first, but some problem you might see might require you to call an experienced hand, which is a resource constraint on smaller organizations. All right, so for the discussion, what is the purpose of firewall in network security? How do firewall filter network traffic? So you just read through it. How do firewall filter network traffic? We talked about this. How do firewall play a role in protecting against viruses and malwares? What is the difference between the inbound and the outbound firewall role? We talked about inbound and outbound. So inbound simply means something that is coming into your network, while outbound means something that is leaving, something that is going out of your network. So if you have any questions, please drop the question in the link here. Then, all right, so I've jumped to videos here. So we have the first link, basic FLP. What's the first link? It's very, very interesting and very, very simple. You might have issues with the second one. You don't need to do the second one. So just only do, and I'll edit this. I just want you to just see the second one, is just for you to see that it is possible to do some sort of cybersecurity work on the firewall. But all you need to do for the first one is that you just watch the video of the first one and do a bit of practice of what was done in the first video. Take your screenshot and paste it on Word. You get. All right. Thank you very much. Do have a very wonderful day. Bye.